Hey everybody, this is Larry. This is day 13. I knew that. I don't know why I had to wait for the thing to see. Day 13 of the Leetcode Daily Challenge. Hit the like button, subscribe, and join me in Discord. Let me know what you think about today's farm. This is going to probably be the last video you'll see it from New York, at least this year, or at least until the end of the year or something like that. So, and I'm not gonna lie, I spend I spend a lot of time in Soho just like shopping for last minute things, but also I'm packing. I'm spending a lot of my time packing, so this video may be a little bit of a rushed one. Though last time I said that, it turned out to be a hard problem. It took me a long time, so we'll see. But feel free to kind of come to Discord, ask questions, etc., and let me know. I know not everyone is into Suckerverse, which fair enough. But yeah, if you're curious about my travel, then yeah, I mean, check out my Instagram, hit a follow, hit some likes on my videos or photos. It doesn't bring me any money, not gonna lie. It just brings me some joy. So if you want to make Larry slightly happier, then do that. But it's okay because probably Instagram is no bueno anyway. But in any case, all right. Without further ado, because I have a lot of things to do, let's take a look at today's problem. We have 3228, maximum number of operations to move once to the end. You give a binary string, you perform the following operation on the string any number of times. Choose any index I, where I plus 1. So you have 1 and 0, and you want to swap, is it? Move the character to the right until it reaches the end of the string or another 1. So you can actually, in one operation, you actually go 2 spaces, right? I think the first thing to realize, unless I'm misunderstood, right? Oh, maximum. Oh, I misunderstood. Because I was like, because usually I would, I don't know. Sometimes, I guess there's a little bit of a sidetrack. Feel free to fast forward a little bit, but I was going to say because I think sometimes I get a comment on my YouTube video or my contest videos more specifically, because during my contest videos I'm trying to get as fast as I can, and sometimes I feel like, how do you read so fast? How do you And honestly, the answer, especially for Leetcode easy problems, there's some parts of it is guessing, and what I mean by that is that I guess what they're going to ask, and then I do, and by the time like I read half of it. Or like maybe I say I read these things like maybe up to here, I would already guess what the rest of the problem is, right? And it's almost like actually the way that you can think about it, since we're all nerds here, it's like branch prediction, right? I keep reading, of course, but if it confirms what I said, I already thought about it and I'm already thinking about how to solve it. And if I'm wrong, then I have to reset, but that's okay because and with easy problems, and you get enough practice, and I don't mean easy problems, but I just mean like problems labeled easy, and especially on Leetcode where they don't really hide things as much, whereas it's Code Force, they would hide it behind the language and the visualization and stuff like that. It enables you to kind of do them very fast, right? But sometimes your branch prediction is wrong, and that's what happens. Anyway, that's a little bit of sidetrack, and that's why when I'm like, maximum number of operations, not what I would have expected, because I would have expected like minimum operations. And if it was min, then it is just the number of it's just the number of ones that would not be at the end, because you would just move to the end. But because this is maximum and not minimum, then we have to think about something else. Though the principles is still the same, or similar rather, just because as I said, I mean, if you're trying to minimize something to maximize it, at least for this one, because it's one dimension, then not many different choices, right? So that's kind of the thought process. And the idea then, right, is that and I think this is very intuitive if you give it some thought, is that you probably just want like some stuttering step, right? Like for example, you have someone like this, there's just a random string. Maybe the minimization would be like to move this here, then here could almost fall all the way down, right? But now we want the opposite, because that is the minimum. We actually want to move this one first, so then it goes 01, and then now we move this one, and then now we can move one at a time, kind of thing, right? And that's kind of the idea. The hard part, of course, is that if you try to do that simulation, it'll be n squared, which for certain values of n is fine, but 10 and n is 10 to the fifth, so that's not going to be good enough. I would say though, yeah. But I would say, and the way to make this faster, at least in like concept and visualization, is just try to figure out a way that allows you to not recalculate moves, right? Or something like that. In this, I mean, obviously, if you say moves, it may be specific to this problem, but I just mean like it allows you to kind of not recalculate things that you might already know, right? And what I mean by that is that if we go back a few steps, let's just have like a checkerboard, one dimension thing. If we know that here, as we always said, we want to move maybe the leftmost one, right? So now it's 0, 1. And then now you can say, oh, well, yeah, now you have these groups of 2, and then you just move 1 at a time to here, right? But you can also, I don't know if I messed it up, but you can also go back a second, and now instead of moving 1 at a time, you move 2 at a time, right? And that's basically it. I think that is the idea. There are some, because now you move 2 at a time, meaning that so that means that, because whenever you make a move, I guess I should finish the reduction / proof, is that when you make a move, let's say of these two things, that means that you always stop at a 1 or all the way to the right. And if you stop at a 1, then now that means that every time you stop, you combine one number or one of the ones. And when you combine one of the ones, that means that since there are at most n ones, you combine n times, and that will give you the answer in all of n times, roughly speaking. Maybe there's some, there's some maybe like minor things that you can think about that may or may not make your programming or implementation easier. One may be that, like, just think about zeros. Like, if I have something like this, then this 1 would go all the way there anyway. So then the question may be that, like, is it like, can we just compress these zeros? And then the question there might be, okay, I mean, maybe we can, I don't know. I think we can, but I'm not going to spend time thinking about it, because the next part is that, okay, let's say we can, how much time does it help us with respect to implementation? Like, would it, because like does it add to the complexity? That's one. Does it, I mean, okay, like you're trading some thought process or algorithmic complexity for some maybe implementation complexity. And then for me, I'm like, oh, well, yeah, but is it really worth the implementation? And then maybe the answer is yes, because you can do the compression of zeros in like 2 lines, right? So that's kind of the idea. There's some like cases you have to think about as well. So you have like something like that. But I think we can just take the chunks and then the zeros, because there's no way for you to kind of say, for example, actually, I guess I'll just use one that's, let's say you have something like this, right? Whatever, right? There's no way for this one, as far as I can think of, to kind of just like stop here, right? Because it has to go all the way to the right to the 1, right? So in that sense, yeah. But then now, as we kind of think about it that way, then now we just have ones and zeros and groups of ones and groups of zeros. And then as a result, we can just go through the loop and then combine them going from left to right. And now we have a 1-pass solution, right? And I think that's it. How long? 9 minutes talking. I mean, I think that's fine, right? Yeah, I think that's it. So let's start implementing. And what I'm going to do actually is going to be a little bit lazier and just use group by, right? I think group by itself is fine. We don't have to write anything special because we just combine the 1. Because basically what we're doing is that we're just grouping the zeros and grouping the 1s, right? So then now we have for x. I always write x and t for some reason. I forget why. I sometimes write g and t for the group. I actually don't know why. It's just my convention. You have to figure out your own. But yeah, okay. So T is the list. So and for this one, you don't need to know the contents of the list. You just need to know the length. And technically, I always convert to a list just in case. The reason is because it's often an iterator. Actually, I don't know if it's an iterator or not. But I think it's free if it can work, but let's actually play around. Let's print it out. Today we can learn. Yeah, so you can see that it's an iterator, right? So that's why I always convert it to a list. I don't even think you can do len on it then, right? Yeah. I mean, the thing about, even if you can, it's a little bit sloppy because you may try to do it again, but on an iterator, at least in some languages, and this is good that you cannot, but in some languages, you know, like iterate, like it doesn't reset the iterator, and then you end up like in a state that you do not appreciate. So that's why I usually convert to list, unless, you know, especially for iterators where you have to use the entire list, and there's some space. I don't know. Now we're getting into the weeds. I mean, it's not necessary, but I just want you to know that I've thought about these things. But in any case, yeah, L, let's just say L is the length of this list, and then we just start with G, right? So if G is equal to 1, oh, and then maybe like a current, and then maybe we define these things with, and total is just the number of moves, right? Operations. Current is the current total group, total is turn group of ones we're pushing to the right. And I guess I kind of skip a little bit, but what I mean by, and we keep track of that because if we have something like this, we want to move one at a time, then that means that if you have a group of 4 ones, to move it to combine to the next group, it'll take 4 operations, right? Yeah, and that's it. So that means that, okay, let's say we are, there are some like things here. So maybe we can say at 0, on 0, we add, right? So if there's 0, then total we add it to length, right? Because now if we add a group of zeros and we have ones to the left of them, we can just come, you know, the whatever, oh, not L, sorry, current, whoops. And the length itself doesn't matter. I mean, I had that's a pretty bad typo, or I don't know, confusion anyway, right? But yeah, current is just the number of ones to the left, and all of them gets moved now to where the 0 is, where it cannot move anymore, or the end of the string, right? And then now else, if G is equal to 1, which is just an else, I know, I just want to visualize it, then current, we combine it to the L, to the current group, and then we should be good. And we are not good. Why? Oh, I know. Because this is a string, so G is equals 0 is wrong. How did? Oh, because I guess that one's 0. That's a sloppy thing that you get from group that I have. It happens to me so often that that's why I'm able to solve it really quickly in case you want, or like figure out why that it was the string, because I do that all the time. All right, that looks okay. Let's give it a quick submit. And there we go. That's it. You probably don't even need to use group by, right? That's probably how the performance thing, and you definitely may not. I mean, you may even only convert it to a list if it's ones, for example. That makes it slightly faster, but I think most of it is just from the group by probably. So yeah, you could see that it already moved a little bit faster, but I don't know. I don't really care that much about it per se, but I just want to point out like some minor things that you can do. Yeah, what did I do last time? I'm curious. I mean, I guess I just did it. I mean, this is basically just, I count this backwards in some way. I don't know. It's probably, I don't know. If you're curious about that, watch it that way. But yeah, but as you can also see, I mean, that logic I think is actually slightly different in visualization and idea and algorithm. But definitely check that out if you're curious. But yeah, this is going to be, I mean, I say one pass, which is a little bit, I don't know if that's quite true in the sense that group by, you could maybe consider that a second pass, though we don't convert it to a list. So and as an iterator, it probably does one pass, but then you have to do this thing, which maybe makes it not one pass. I don't know. I mean, that's why this is a little bit slower than the other ones, but the complexity will be the same, which is still linear time and technically linear space, I suppose, because of the group by and this. So you can definitely do better than linear space if you're really careful. Yeah, but I mean, yeah, this is all one space, for example, but somehow about the same memory. So oh no, actually much smaller. I don't know, it's fine. Anyway, that is all I have for this one. Let me know what you think. Thanks for watching. Yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.